domain-specific languages in Ruby Talk, and my name is Neal Ford. All the slides and steps I'm going to show you will be available on my website at the end. Questions along, I've only got 45 minutes, worked out that creative tension. This is a talk about building domain-specific languages, and I'm actually going to start with something that is a little on the obscure side, and a little bit about the motivation for building domain-specific languages, and why you want to do that, and why that is a way to generate code reuse and improved abstraction over some of the techniques that are a little more traditional and the kind of statically typed, non-dynamic world. And we'll see some examples and talk about who the consumer of your language should be, and lots of examples as we go along. So, DSLs really represent kind of a throwback to some techniques that were developed a long time ago. And the parallel that kind of strikes me here is this parallel between classical art, which is art created by ancient Greeks. They created a whole bunch of art, and then of course civilization crumbled and fell. And then a few thousand years later, during the Enlightenment, after the Renaissance, a lot of Europeans picked up the exact same techniques and subjects of classical art and read them using modern techniques, using modern tools. So a lot of the subjects were the same, a lot of the compositions were the same, neoclassical art as they were in classical art, just with better techniques, better tools, and kind of a rethinking of the same kinds of things that you saw in classical art, but for a new generation. And that's kind of what we're looking for and when we look at domain-specific languages, because this is a technique that was really widely used back in the ancient days of computer science when Lisp reigned king as a way to write domain-specific languages. Before we had objects, and before we had object-oriented programming, one of the accepted ways to create abstractions in computer applications, in computer programs, was to use a domain-specific language. And unfortunately, we got kind of away from that when we started using objects as our abstraction mechanism, but this is still a really useful technique, and that's what I'm going to talk about today. So let's talk about a little bit of nomenclature and get that out of the way. This is stuff that's coined by Martin Fowler, where a domain-specific language is a limited form of computer language designed for a specific class of problems. Traditionally, domain-specific languages have been used just to represent specific problem domains. So they represent the kind of application that you're trying to solve for a business case, for example. But it turns out that DSLs are for any kind of thing where you create your own custom language. So I follow the uses that uses DSL to be applicable to any limited problem domain. We'll actually see that there are a bunch of DSLs created strictly for developer consumption, like Rake, that doesn't solve any business problem, but makes the job of a developer much easier. And then language-oriented programming is a style of development built around this idea of using DSLs. Just as object-oriented programming is a style written around objects and classes and trees as your abstraction mechanism, language-oriented programming is the same for creating DSLs. It turns out that DSLs are all over the place. You use them all day, every day. I used one this morning on my way to the convention center when I stopped by Starbucks. Starbucks has a really, really well-known domain-specific language that allows you to order extremely precise coffee in a variety of different ways without having to go into a huge, long API-style description of what you want from the barista. The second one is probably one that nobody here will recognize as a domain-specific language. I'm from Georgia. One of the things we have in Georgia are Waffle Houses. And in Waffle Houses, there's a domain-specific language for how you order hash browns. So scattered, smothered, and covered is 3 of the 5 options for ordering hash browns at Waffle House. If you never go to a Waffle House, you'd never be clued in that there's a domain-specific language in Waffle House, but there actually is. The third one is pretty recognizable. It's musicians. Notice that a group of musicians who have never met each other before can meet and within a few cryptic sentences to an outsider decide what song they want to play, what style they want to play it in, the special effects that are going to be in the song, like an extra repeat of the chorus at the end, and they can play together even if they've never met each other because they speak the same domain-specific language. It sounds completely obtuse to someone who doesn't know that language, but to someone who understands it, it makes perfect sense. The fourth one is actually the beading domain-specific language that my wife is very fluent in, and I know nothing about. And then the last one is the cricket domain-specific language. It turns out that most sports have their own domain-specific language that goes with them. It sounds like gibberish to someone who doesn't know that sport, but it makes perfect sense to someone who does. So this kind of abstraction actually exists all over the place, and we use it every day. You just maybe don't realize it. So one of the questions that you have to answer when you start talking about DSLs is what is the distinction here between an API and a DSL? Because they address some of the same problem space. An API is some sort of framework that you've created to solve a particular problem, like an XML parsing framework or a user interface framework, which consists of a whole bunch of classes that are organized together in a very specific way and has very specific calling conventions defined within the framework. And in fact, a lot of programming is learning the framework defined by your platform. So you can learn Java syntax in about a day and a half, but to learn all of the libraries that go with Java, the framework that makes it up, is what really determines your mastery of a particular language or not. In an API, you have a very explicit context. You always are dealing with that context. So if you're dealing with an XML context, you're always very explicitly passing around XML documents and artifacts of XML documents. And you're passing those as parameters, and you're creating objects of that type and dealing with those things very explicitly. And the way that you make those things do something is via object messages or parameters. A DSL is a little different. A DSL has an implicit context. Notice in the real world DSL that I have over here, the first and the second one and the third one and the fourth one and the fifth one don't actually explicitly say what they're about. The first one never uses the word coffee. The second one never uses the word hash brown. And yet, if you're familiar with that DSL, you know what they're talking about. The same is generally true in domain-specific languages that you create in, for example, Ruby. The context is there, but it's never explicitly said or passed around, or nothing is ever done with it explicitly, but it's always kind of there. There's this implicit context that exists, but you know that it's there. So in the little example I have here in the corner, I'm going to show you a much bigger example of that later, but this is actually a domain-specific language written in Ruby for appointments, where it says dentist appointment at 4 p.m., dinner in Tahiti, lunch with the president from 12 p.m. to 1 p.m. Nowhere in there does it say anything about calendar, but that's really what we're dealing with there, is a calendar application. And so that's one of the subtle distinctions between an API and a DSL. So here's a kind of explicit example of that. If you were creating a coffee framework in Java, it would look something like this, where you'd say coffee.new, and you'd have all these properties that you set values for. Notice that there's a very explicit context there, which is that latte instance variable, which is on type coffee, versus the DSL version, which is venti, half calf, non-fat, etc. The context is completely implicit there. There are a couple of different kinds of DSLs you can create. And one of them is an internal DSL, which are domain-specific languages built using the syntactic elements of the underlying language. And that's mostly what we're talking about here, because we're talking about building DSLs in Ruby. And in fact, that's the way that most DSLs have traditionally been built, is on top of another language. So Lisp, Smalltalk, and Ruby have done this to build a domain-specific language on top of the syntax that already exists. And that makes sense because if you already know Ruby, then it's fairly easy to build a language layer above Ruby, but still be able to drop down to the actual Ruby code if you want to. Of course, one of the restrictions here is that you have to know Ruby before you can really build a DSL on top of Ruby. In fact, some people would suggest that this was basically a defense mechanism for Lisp programmers, because the last thing they wanted to do is spend a lot of time writing Lisp code. So the first thing they did was build a higher level language above Lisp that they could live in most of the time, and then just dive down to Lisp when they absolutely had to. But what this allows you to do is build on top of your language things that make sense in your problem domain. So what you're doing is building layers of abstraction further away from the details, the atomic details, and closer to your problem domain. And notice that that's basically what we've been doing in computer science ever since we got away from zeros and ones. We've been building away from the metal and creating higher levels of abstraction. A computer language is one level of abstraction, and domain-specific language on top of that is another level of abstraction. Internal DSLs, no matter how much syntactic sugar you put around them, are mostly for programmer consumption. So it would be very difficult to create an internal DSL in Ruby and hand it to an end user if you did not also create some sort of tool to edit it, because they would very quickly get into syntax trouble. Because even Ruby, with as flexible and as easygoing as it is about its syntactic elements, if you get something in the wrong place, the compiler's going to yell at you. If you don't know what the compiler message means, then you're in trouble. The other type of DSL are external DSLs, which are actually explicitly new languages created by a compiler. There are a bunch of examples of these out in the world, and there are a bunch of compilers out there, the kind of old school Lex and Yak, and the new school of Antler and JavaCC and the Gold parser builder. And this includes XML. Notice that one of the reasons that there's so much XML configuration stuff in the Java and the .NET world is because they wanted to abstract out those configuration details away from the actual code and put it in its own language. So that's where all this XML comes from. And I can't resist talking about XML without talking about my favorite quote about XML. XML is like violence. If it doesn't solve your problem, you're not using enough of it. All the XML that you see out in the world is really just a domain-specific language for configuring a framework. And so even platforms that are strongly typed like Java and .NET are actually using this technique all the time. They're just not calling it that. And most external DSLs are for user consumption of some kind. So you can see we're building up this really elaborate, building your own new language and doing code gen underneath. You can get something that's much friendlier to an end user. Ruby is particularly good at building internal DSLs. And that's what the remainder of this talk is about, building internal DSLs in Ruby. Because Ruby has a lot of forgiving syntactic sugar that makes it possible to build DSLs. We have open classes. You can crack open any class that you want, add some new behavior to it, which comes in really handy. An example I'll show you in a second. It's really easy to parse strings because you have regular expression support built in. You have the missings, constant missing and method missing, which allows you to do all sorts of magic tricks at runtime for methods that don't exist, but get synthesized in real time at runtime. The way that you can do name parameters and symbols as hashes, and the loose rules about parentheses for method calls, all these things are basically syntactic sugar for being able to create a language that looks just like you want it to look, but it's actually functioning Ruby code. So let's look at a simple example of this, taking advantage of an open class. So there's an integer class in Ruby, and for my countering example, I want to make the integer class time aware. So I want to add the concept of AM and PM to integers, so I can say 1.PM or 12.AM. And so that's really easy to do. You just say class integer, which opens up the class, and add your new definitions inside it. And I can take advantage of this in my calendar program because one of the things I need to do is to create start and stop times and be able to compare the differences between two times. So you need to think about who is your consumer when you decide to create a domain-specific language. If it's programmers, then it's okay if your DSL looks a lot like code. And here's an example from the Rake file that comes with Ruby on Rails. Rake is a great example of a domain-specific language that's built on top of Ruby that looks kind of like a make file, but it also looks a lot like Ruby code. So this is right on the cusp of between a domain-specific make language, and Ruby code. And in fact, at any point during a rake file, you can kind of play with that boundary all you want. So this is certainly recognizably Ruby code with a block and where vendor lives.each do. That's clearly a block. And so this is both Ruby code and make code all together. I'll talk more about Rake in just a second. Another one that is most people here are probably familiar with is active record, the way that active record works in Rails. That's one of the really interesting moments when you're learning Rails is when you first look at an active record definition where you create an active record and it's basically just an empty class. But it's smart enough when you go and ask it for the name field from the customer in the database, it'll actually come back with a value. The way that it does that is with method missing. So when you inherit from active record, you also inherit the method missing behavior that's built into Ruby, so that active record can go off, and when you request something that doesn't exist, some attribute that doesn't exist, method missing can catch that, find out the name of the thing that you're looking for, and go synthesize a method on the fly that will return that value for you automatically. That's a great example of creating a really, really flexible domain-specific language for being able to fetch stuff out of a database, because you can basically synthesize behaviors on the fly based on the characteristics of what your user has asked for. One of the other things that you can do in a domain-specific language is switch a context. Let me show you what I mean by that. This is a simple domain-specific language that helps you model the relationship between records of some kind. And you can think of this as modeling records in a database. In fact, I have this over here in TextMate. This is my class model, which has many cows, and a cow has one farm, it has a property name and an age, and it has an initializer. That looks like pretty standard kind of mundane kind of code. Although it's not necessarily identifiably Ruby code just on the face of it, because we've added some different methods like has many, but it's still recognizably code. What's interesting about this particular example is that if you add a required model to the top of this file, it generates a list of fields and associations ready to generate the database schema for you. So requiring model at the top basically changes the behavior of what this source file does, because now it will go off and generate a database schema. And it does so via this class. So class model, you'll notice model is what we inherit both farm and cow from. Class model has, every time it encounters a property definition, it goes off and builds up a list of field names, so that ultimately what it can do is generate a list of fields so that you can generate a SQL statement to be able to populate this schema into the database. But if you require draw a diagram up at the top instead, that changes the definition of what model does, and in this case, it generates an ER diagram of that model. So here's the class model that uses dot to generate an ER diagram based on the same kind of functionality that I've defined in that model file. And basically what this is going to do is use a GraphViz and dot to generate this diagram. You can see right here, this diagram is actually generated from this model file. So you can take a single source, this, and generate completely different artifacts from it just by changing the thing that you require at the top. So this DSL actually describes more than one thing. It describes a database schema, but the way that you can project that database schema may be in SQL code, it may be in some sort of text file, or it may be as an ER diagram. And the definition of the language doesn't change. It really just depends on the things that you say you want to do with it by just changing the require at the top and the bottom. So, as I said before, you have to think about who is your consumer. Because you can create DSLs in Ruby that are virtually indistinguishable from English if you want to. And it really depends on how far down the rabbit hole you want to go in creating a human-readable version of a DSL in Ruby. And my example here is this calendar language. Here are 3 lines of code for my calendar language. Dentist appointment at 4 p.m., dinner in Tahiti, or lunch with the president from 12 p.m. to 1 p.m. That is actually Ruby code. Even though it doesn't look very much like Ruby code, it looks like descriptions from an appointment book. But it is in fact Ruby code that gets parsed and executed as Ruby code. And you'll see at the top that plans is exactly the same stuff I have there on my slide. But you can also look at it this way. From a programmer standpoint, what's really going on here is that I am, each one of those are methods. And I'm just skipping the parentheses for each one of those method calls. So basically what I'm doing here in this example is chaining together a whole bunch of method calls, but leaving the parentheses off so that it looks like regular text. There's lots of interesting stuff going on in this example. So this is what it looks like to actually parse one of these calendars. This is calendar is equal to calendar context.parse plans, and for each one of the entries, I'm going to write out what this entry does if there's actually a value for that entry. And it turns out that this example will work whether I use plans or explicit plans. If I change that value, both of these work exactly the same way. So let me show you how that works. This is a calendar context which inherits from the DSL context. And you'll notice that what it does is basically called parse. Well, parse is actually defined over here in my actually a calendar context, where it says I want to parse the appointments. It creates an empty array of calendars and then does execute appointments on it and adds each one of the appointments to the calendar. So what we're interested in here is the execute method. Well, execute does actually come from my DSL context, which actually has 2 things in it. First, it has my integer class that defines the AM and PM behavior for integer because I'm doing time periods. And then it has this DSL context class, which has execute in it. So what execute is doing is going through and polishing the text. Polishing text means that what I need to do is get rid of the new lines in my plan, because that doesn't make any sense in my language. And this is a fairly subtle thing. I need to remove reserved words. You'll notice over here that my N right there is actually a reserved word in Ruby. When I convert this to a series of method calls, I actually convert it to underscore N so that it doesn't conflict with the built-in keyword in Ruby. Because ultimately what I'm going to do is actually pass this whole string to something so that it can evaluate it. And of course, having a reserved word in there where it doesn't need to be there messes things up. So I remove the reserved words, and then I call decorate rule. Now, decorate rule does not actually exist in DSL context. It exists over in my calendar context. That's the thing that's actually taking care of building up these rules. That is, in fact, right here, just add that rule for me. This is the place where if you were building up more than just a list to print out these rules, you would actually do something like make an entry into an iCal file or something like that. In this case, I'm just adding this to the list as saying I'm adding this rule to my list. But here you can do all sorts of stuff. And notice that Ruby doesn't really care that this is a method that's not defined here, because at runtime it's going to call the right thing. And then the result is context on instance eval that rule, so it's actually going to execute that rule. And if that rule ends up as a block, then it's going to yield and let you execute whatever code is in that block. So that means that this language will accommodate actually including a block as one of the statements in this language so that it can execute it. And the rest of this is basically just cleanup for the add method, for underscore in, for place, for to and from, which take a time, and an at, which takes either a time or a place. You look to see if time or place is a string, then it's a time, it's a place, otherwise it's a time. And you can see, when I run this, it actually prints out dentist appointment, start and stop time, and etc. Now, one of the things that I'm kind of doing in this particular example is cheating just a little bit, because you'll notice that it's yelling at me about all these missing parentheses. If you want to push Ruby this far to create this English-like domain-specific language, you are actually doing something that the Ruby interpreter complains about. Namely, what you're doing is calling a whole bunch of methods with missing parentheses, and that's all those parenthesized arguments, warning that you need to parenthesize those arguments for future versions, because they're thinking about strengthening the rules on that for future versions. So a future version of this very English-like language might have to change if they stiffen the rules as they are leaning toward in future versions. But for now, I can kind of get by with this with just basically a slap on the wrist warning. And as you can see, if I change this to the explicit plan, it runs it correctly this time, and it doesn't yell at me about all these parentheses because I've already parenthesized my method calls. And of course, this one is a whole lot uglier if you're trying to create a human-readable domain-specific language than that one. So this is a bit of a stupid Ruby trick in that you can get by with leaving off all those parentheses and create something that is pretty close to English and still be able to execute each one of those things as methods. If you're willing to put up the warnings, though, and if your end user is never going to see those, for now at least you can create these really, really explicitly English-style domain-specific languages in Ruby. In fact, one of my colleagues has created something that goes even further along those ways. This is the J. Fields casino language. J. Fields is one of my colleagues at ThoughtWorks who's been doing a lot of this kind of work. And he's actually created a language that has ignorable keywords in it. Because another thing that you can do, a lot of the contextual words in a domain-specific language are things that you don't really care about from a programming standpoint. Words like the or etc., you can actually just get rid of those. So one of the things that his language does is actually pull out the words that he doesn't care anything about. They're basically just there to make people happy. So you can actually, in Ruby, get pretty close to all the way the natural language processing kind of abilities, just by using the internal syntax of Ruby without having to build your own grammar, your own parser, and all those other mechanisms that you normally have to build in another language to allow you to do that. So when you build a DSL in Ruby, you really just need to figure out what you want it to look like. There's a great story about the origins of Rake, which Jim Wyrick was right here, he's the guy who created it, that they didn't really set out to build a new Make language necessarily. They were struggling with Make and said, you know what, it'd be a lot more friendly if this thing were written in Ruby, so they sat down and sketched out what they thought the language should look like. and then realize that they can actually implement it fairly easily. And you iterate over that 4 or 5 times for new features, and before long, you have a nice language like Rake. And I think that's actually the best way to go about building a DSL in any language, particularly something like Ruby, which has such flexible syntax. You're better off actually writing out what you want the language to look like first, and then making Ruby do that, rather than trying to start from some abstract definition in Ruby code and work that towards your DSL. Start with what you think it should look like and work backwards to make that your actual Ruby code. And you need to consider who your consumer is going to be. If your consumer is a developer, then it's okay to create something like Rake, which is very identifiably code, but just operates at a higher level of abstraction than the equivalent code would. So in some ways, building up a really intelligent kind of API where you don't have to pass a lot of stuff in and out very explicitly. If you're building it for an end user, you're better off building something that looks very, very close to the problem domain for that end user, and then get Ruby to actually generate the code that you want for it. And in fact, in a lot of cases, what you might end up doing is building not only a domain-specific language, but also an editor that allows your end users to work in that language safely without accidentally breaking something. And that's actually a fairly important thing, because it's pretty easy over here, if you're trying to give this to an end user, for them to break something. Especially if they're especially if this is somebody like a reformed Java developer or something like that. And then they want to come in and put nasty characters in there. Actually, it was okay with that. But there are certainly places in here where you could add something that cause bad things to happen. And of course, this is extraordinarily cryptic to an end user, because, hey, I thought I was just adding a calendar entry of some kind, and now I'm getting this bizarre parse error expecting semicolon, expecting open brace. Obviously, that would never be good for the end user, so it's probably a good idea to actually protect them by building something that only generates the correct kind of code. And make sure that it makes sense in the actual problem domain that you're dealing in. Now, we're following some very interesting paths. We're currently writing a book on this subject, and some of the paths that we're following to build domain-specific languages for is getting rid of explicit configuration files. As I said, a lot of the external DSLs that you see in use today in the Java and the .NET world have to do with configuration. And you're actually better off writing that kind of stuff in actual code if you can find a nice DSL syntax that encapsulates what that configuration information is. I showed you an example of executing in different contexts, where you can actually switch context, have the exact same domain-specific language, and switch context and completely change the output artifacts that you create from this language, from schema to an ER diagram, etc. As I said, you can start tiptoeing toward natural language processing, although this is one of those things that the more toward natural language processing you get, the more and more complicated your rules become. The more and more stuff you have to start ignoring, and the more and more ambiguity you have to start handling, because obviously natural language processing is, there are some things in that that are very, very ambiguous. But as long as you keep yourself to a very limited problem domain, you cut out a lot of the ambiguity, because it should only have one meaning in the problem domain that you're dealing with. You're also, when you're creating DSLs, creating self-documenting code, because the code is so close to the problem domain, you can actually show it to an end user and let them verify its correctness by sight, versus having to translate it for them. You cannot take Java source code or Perl source code now and show it to your user and have them verify that it's correct. If you have something that is fairly English-like, or even in the ballpark of English-like, they can look at it and verify it on site that it is in fact correct. In fact, that's something that in the the language-oriented programming world is considered a projection of the code where you project it into some other format that is verifiable or understandable, just like the ER diagram that I created there. And then finally, testing. There's some work being done at my company, ThoughtWorks, right now. We've created this tool called Selenium that helps you test web applications. And we're writing a domain-specific language for Selenium that will drive Selenium from this DSL. So it's a perfect candidate for a DSL. It's a very limited problem domain. I need to be able to drive this testing utility, this testing program. So this domain-specific language is going to drive Selenium to make it do stuff in a very, very specific, very constrained way. So language-oriented programming is kind of a classical idea for a neoclassical world. It's a higher level of abstraction from what we've mostly been dealing with when we've been dealing with objects as our main abstraction mechanism and object hierarchies. I think this is going to be a huge programming paradigm shift. We're going to start seeing the use of internal DSLs and dynamically typed languages a whole lot more, and then language workbenches for statically typed languages. Because there are manufacturers right now, JetBrains, the guys who wrote the IntelliJ IDE, are building a tool called a language workbench that generates domain-specific languages using code-generated Java. Microsoft is working on this as well in this initiative they're calling software factories. And then Intentional Software, which is a company founded by an ex-Microsoft employee, is also working on this from the C#.NET world for creating an IDE that generates domain-specific languages. We actually have an advantage in the Ruby world in that we already have a good palette for writing domain-specific languages on. And in fact, the kind of tipping point for a lot of people to start recognizing Ruby for how powerful it really is Rails, which is itself a domain-specific language for building web applications with persistence. That's one of the reasons why people rave about what a joy it is to use Rails. That's why it has this kind of exuberant, unexplainable joy that people find when they use it, because they're using a tool that exactly fits the problem they're trying to solve. And anytime you have that, then it's much easier to use the tool and get work done. And I think this offers a huge competitive advantage because all of your code is abstracted closer and closer to your problem domain and further away from the curly brace and the actual language syntax that defines the atomic behavior of your application. These are clearly harder to write than just regular code, but they're much easier to maintain because ideally your domain-specific language is going to be very close to the problem domain you're trying to solve, and as your problem domain changes and migrates over time, your language can change and migrate over time. And of course, this also has the benefit of being able to show it to actual business people so that they can verify that it is actually correct. I've got a little bit of time left. Does anybody have questions about any stuff? Yes?
How vulnerable is a DSL to a code injection security breach?
No more vulnerable than any other API. I mean, you can certainly handle that internally within your DSL. So let's say that you decided that some incredibly malicious person had decided that they wanted to hack my calendar, my little calendar application. They wanted to inject some nasty code in there. Well, at some point, when I call decorate in here, it's when I decide what to do based on that rule. I can add whatever safeguards, other kinds of moat around this code that I want. Execute it in a limited sandbox context, for example, to make sure it doesn't get nasty. So this is no more prone than any sort of API that you have out in the world, but probably no less prone to sort of shenanigans like that. Yes?
Well, given that it takes a while sometimes to set up these DSLs, when you're coding something in a new domain, how long do you sort of program it the normal way before you decide you're going to sort of bite the bullet and do a DSL? Like, how does that transition usually work?
That's a good question. His question is, at what point do you decide, wait a minute, I should stop coding the way I am now and code this into a DSL? It really depends on, are you dealing with a nice, well-defined, limited problem domain? Because if you have that, it's really the boundary that you care about. If the boundary is tight enough that you can actually reasonably create a small language for it, then I think that that should be the tipping point that, yes, that's what we want to do is actually build a DSL.
They're sort of like telling signs, like you find yourself writing this sort of code idiom over and over again, and you think to yourself, oh, if I just made that into a DSL function name or something, like you sort of.
I think it's even more than that. That's certainly one of the telling signs, that you write the same idiom over and over again. But if you find yourself creating the same kind of data structures, and if you can envision those data structures as something that's, that could be better described in English than in some sort of class diagram. The way that we typically do this for clients is actually go interview the clients and write down what they're saying, and then take that and kind of mold it into a domain-specific language. That's actually an interesting exercise, because when you have to write this stuff down, it has to be very precise. And you'll find out that they have kind of a fuzzy understanding of the stuff that they were building, and that gets it exact. And once you have that exact representation, then you just build code underneath that as a kind of support. So I think you're much better off writing down the language that you want and then making Ruby do that versus trying to build it from the ground up the other way. So we'd probably be more prone to actually start a project as a DSL than to morph it into one once we started building hierarchy and that kind of stuff. And it's definitely a mind shift to think about that, because we are trained mostly to build hierarchies, build trees out of things, relationships. And this is definitely a mind shift, because it's a completely different level of encapsulation and abstraction from what we're used to.
It's just Kernighan's thing of, I'd rather write programs that write programs than write programs.
That's exactly right. Straight out of the Unix, art of Unix programming, the Eric Raymond thing. I think it's rule number 14 is to avoid hand hacking, write programs to write programs when you can. That's exactly what this is write a program that writes a program and operate at a higher level of abstraction. That's really what it's about. Yes?
You said that they're more difficult to write but easier to maintain, but it seems they may be much harder to debug.
It depends. If it's really close to your problem domain, then sometimes it becomes even easier to debug, because you know what the messy parts of your problem domain are, and chances are pretty good that that's where the majority of your bugs are going to end up, is getting those things right. Once you get past the initial recognition of the syntax of the language, then most of the messy problem parts are going to be the messy debugging parts as well. So I think that having a good understanding of problem domain actually leads you to the place where you're going to spend most of your debugging.
The other
That
advantage
seems-
is once you've got it done, you've solved it for every case, and you don't have to.
Exactly, and as your problem domain evolves, then your language gets to evolve in lockstep with it. And really, I think it's the realization that not everything in the world fits into tree-shaped hierarchies. That, in fact, not everything is tree-shaped. So there's a whole bunch of work now in the Java.NET world creating aspects to cut across the tree hierarchies. And what they're really doing is trying to map, and it's an impedance mismatch with the real world and the way you're trying to model the real world. And the way that business analysts model the real world is with language. And so if you can create a language really close to the way they're modeling their world, then you can model your world in lockstep with it. Yeah.
So you showed this kind of this cascading composition of functions as your ultimately what's going on with the language you created. But does Ruby support metaprogramming in the way so it sounded like you're familiar with Lisp, so
Yep.
like Lisp's con. So one, I'm creating a syntactic form. I have conditional evaluation of some of the expressions. Right, I'm actually piecing a lot of code around these syntactic fragments. Does Ruby support that kind of power?
Not as far down the rabbit hole as Lisp is.
Okay.
Because you can pretty much build Lisp in Lisp. That's what step number 12 in building out Lisp is you build the Lisp interpreter and you're done forever. It doesn't go quite that far, but it has much, much stronger metaprogramming hooks in it than most of the modern mainstream language we're using now. So you can get to const method missing and method missing. You can get to the way that it's parsing its code. So there's a lot of metaprogramming hooks cooked into Ruby that make it easier to do this. It does not go as far down the metaprogramming rabbit hole though as Lisp does. then I don't think anything gets quite that far down.
So there's not actually like an evaluation semantics at compile time or
There is
at
an
read time?
eval. I actually used eval in instance eval right here for one of these rules. You can take Ruby code that's in a variable and eval it at runtime and execute it.
But can that return code that you splice into the,
This can return code that you subsequently instance eval. But it's harder to plug this directly into the existing syntax tree and keep going. So there's nothing quite like a hygienic macro.
Okay.
Not quite there, but you could simulate something pretty close to that, I think, given enough programming time. Got time for one more question, so.
I'm just curious, I know you were escaping some reserved words, but why you chose to go the eval route. Rails seems to either pick its context by, the fact that classes are evaluated just like any other piece of code, they're executed, and so it assumes it's, context that way, or by placing it in some sort of block and getting the context that way. Was there any reason to go with the val? It seems like the val can get a little more dangerous than some of the other ways of going.
This is a little more dangerous, and given that I only had 45 minutes, I explicitly wanted to go the opposite direction that Rails is going. So I'm trying to show that domain-specific language in Ruby exceeds what Rails does. Rails uses that technique a lot. And I'll show one snippet of active record here, but I really want to show a variety of different ways to do it. It's not too tied to Rails. But there's certainly different ways to do it. You're right, eval is more dangerous because it's a lot closer to actually parsing than what Rails does. So Rails probably takes a more prudent or more judicious approach to it. I'll just do it a lot. Looks like I'm out of time, so thank you very much for coming.